Hi everybody, my name is Biniam and I will be presenting to you the paper Security Analysis of Permission Re-delegation Vulnerabilities in Android Apps. This work was done in collaboration with my colleagues Mariano from University of Verona and Shar from Singapore Management University. This work has been published in Empirical Software Engineering Journal. Considering the limited time I have, I will summarize the whole work in the following slide. So Android has a cornerstone feature, what we call app-to-app communication. If applications do not implement this app-to-app communication properly, it could be abused, meaning that malicious applications could take advantage of vulnerable applications. This vulnerability overlaps with normal app-to-app communication features that developer implements, so detecting this security problem is a bit difficult. So how can we tell whether an app-to-app communication is a vulnerability or unintended behavior that the developer implemented? Our proposed solution is to group together similar apps from Google Play, apps similar to the app under test, and see whether the behavior of this app is an outlier in terms of permission delegation behavior. A quick recap on Android apps. In order for apps to provide an interesting feature, we have to grant them permissions. For example, GPS permission for travel and navigation apps, and contact permissions for communication apps. Let's see an example. Here we have a browser, Chrome. We search for a location and we have this search result. Clicking on the call link instantiates the phone application and we'll be able to complete the call. The browser in this case was able to instantiate the phone application by sending a special message called intents. Intents are abstract description containing actions and data. Action, what the other application has to perform on what data. In this case, the data is the telephone number and the action is making a phone call. And this is called intent-based intercomponent communication or inter-app communication. Let's see, for example, a malicious website abusing this communication. Here we have the same, let's say, search query on a fake Google website. The malicious developer, instead of a phone number, on the call link provided this code. Clicking on the call link, then we'll send the intent with this message. But this message has a different meaning depending on the device. In this case, for certain Samsung phones, this message has a meaning of formatting the phone. And this security problem on the phone application is called permission re-delegation vulnerability, meaning that the phone application kind of gave its permission of resetting the phone to the browser in this case, or to other applications. The existing approach detects this security problem by performing flow analysis. Basically, they see if there is a path from an entry point to a sensitive sink. Sensitive sink is any permission protected API. If there is this path, then the application is reported potentially vulnerable. Let's see again a previous example. We have the browser. Clicking on a link opens the phone application and we will be able to make a phone call. This is a feature that the phone application developer implemented. However, clicking on a link that contains special code and that resets the phone is not probably unintended behavior. It is not unintended behavior in terms of delegating or providing this service to other applications. So we have these two cases. So previous approach would not differentiate between these two cases, but we are interested to identify the security problem, which is number 2. If we use the previous approach, majority of the cases will be false positives. So this is our proposed approach. We collect top applications from Google Play, all applications that are available from Google Play. We perform topic modeling on the app descriptions, meaning that we try to understand what each application's description is talking about, and we group them together based on similarities, and then we cluster them together. Then we learn a model from these clusters, the model being the permission re-delegation behavior. Then once we have this model, when we have an app under test, we first identify to which cluster it belongs, meaning that we identified similar applications. For example, if it is a messaging application, we will be able to locate its group, which contains a list of messaging or communication apps. And then we compare its permission and delegation behavior against this set of applications in the cluster, in that cluster. If we discover that it's an outlier, we then generate test cases. Test cases are intents that execute or exploit the permission or delegation vulnerability that this application has. When we are successful, we output a test case and report saying that this application is potentially vulnerable. We try to answer several research questions, but for the time limitation that I have, I'll try to talk about a few of them, and I will kindly refer you to the paper for more details. Here is our experimental setup. Our training set contains more than 10,000 Google Play apps. These were all the apps that were available at the download time. Our subject apps contain more than 1,000 apps divided between closed source and open source. We then picked two state-of-the-art static analysis tools for comparison. The first research question is regarding precision. Out of the 1,200 applications, our approach detected 30 true positives with 0 false positives. This we can conclude that our classification is precise and did not report any false positives. Regarding the cost, the outlier detection phase on average takes 1.2 minutes, but the test case generation takes on average 25 minutes. From this we can see that the outlier detection is very fast and the test case generation is acceptable because we are going to do the test generation on the outlier applications only. Regarding comparison, we compared our approach with Covert and IccTA. Covert is a static analysis tool to detect privilege escalation or permission leak problems. So this is a perfect candidate for comparison, while IccTA is a general purpose static analysis tool that can be customized in order to detect the security problem to imitate what state-of-the-art approaches are doing in order to detect the security problem. So here we can see that with the open source applications, our approach detected 7 true positives with 0 false positives, while Covert detected 1 true positive and 17 false positives. IccTA, on the other hand, did not detect any true positive and provided us with 15 false positives. Remember that IccTA is modified in order to detect this security problem, but originally it is not designed for this purpose. It's a general purpose static analysis tool. With injected apps meaning apps that were artificially made vulnerable by automatically mutating safe application with the security problem, we have a total of 20 mutated apps, and our approach detected 15 and with 5 false negatives. Basically, we missed 5 security problems, but with 15 precise detections, while the other approach did not detect any of them. So from here we can conclude that our analysis performs better as it classifies more security problems accurately, and the other tools produce more false positives and false negatives as well. So in conclusion, we have seen that intercomponent communication in Android is important. However, if it's not implemented properly, it could be abused by malicious applications. State-of-the-art approach to detect the security problem suffer from false positives. We have to be able to differentiate between intended behavior that the developer implemented versus defect that the developer made. So we propose a novel approach that precisely detects the security problem called permission delegation, and we also make the tool available on GitHub if you are interested. With this, I conclude the presentation, and I kindly refer you to the paper for more detail. Thank you very much for your attention.
Hello again. The last paper of this session is named Security Analysis of Permission Re-delegation Vulnerabilities in Android Apps. One of the authors is Binyan Fisheha Demisie, that is here to answer any questions you would like. So please use the chat to ask your questions. My first question is about the criteria that you use to put together similar apps. For example, did you use very general terms like, for example, games, and you put together all the games, or social apps and you put together all social apps, or are you using more specific terms for the classification?
Okay, thank you for a very good question. So we did not rely on the categories that Google Play provided because prior research has shown that it is not very coarse-grained. So what we did was to analyze the descriptions of applying some NLP topic modeling approach and group together applications that describe or that talk about the same functionality. If an app talks about communication, messaging, based on this description, applications having similar functionalities will be grouped together and then clustered together. Mm-hmm. So basically, we did not rely on what the Google Play category provides us.
Okay, thank you. What happens with those apps that cannot be grouped because they are very strange? Imagine that I develop a tool, a very strange tool for a very specific context, and there is no way to classify this tool. How do you manage to work with those tools that are not easy to be classified?
Okay, so in our experience, at the end, the application will be classified in one of the groups, maybe in the wrong category, but it will be grouped because the topic modeling works like this. So if as long as the application has some descriptions, okay, we extract some topics about what that description talks about, and then based on this topic, either it is in a messaging group or let's say social group, but if the description is strange, for sure the application will be grouped in the wrong category. It will be an outlier in the group, but yes, at the end the application will be classified anyways. Yeah.
Okay, we have a question from one attendee.
Okay.
She's asking, very interesting, could you elaborate more on the approach? Does it mean an outlier here?
Okay, so an outlier here, so in general in this paper is that, so you have a group of applications, let's say based on the classification that we initially did, we have apps that do communication or messaging purpose. And then we have an app under test, a new application to be tested, and we compare its behavior against the behavior of this group. If it behaves the same way, then we classify it as safe. But if it behaves in a different way in terms of the specific security problem that we are talking about, which is permission delegation problem, and then we consider it as an outlier. Okay.
Okay. More question from my side. And how do you validate, or how do you consider that a classification is good or is not so good? Do you have some weight or some checkpoints or whatever?
Okay, so the classification, we relied on previous work, so the methodology that we used, but the evaluation was randomly taking samples from the clustered group to see if they actually belong to similar topic. So from each cluster, we are taking a random sample of applications to see if the classification is actually meaningful.
But can you ensure that the classification, for example, you put a weight and you say, oh, this classification is 100% of perfect. Or, well, the classification is not so good. Maybe it's on 50%. So you have some kind of weights or a scale?
No, so we didn't have a weight. So This approach has been previously, say, studied by other researchers. So for the classification part, we relied the same methodology because our interest was for the next part, like say, okay, we group the applications together with this methodology, and then we follow with our security analysis. Okay. So previously, in the previous work, it has been shown that it works well, better than the actual Google Play categories that are provided.
Okay. And my last question is about your future. What is your next steps in this research?
Okay, so probably as you can see from as you saw from the slides, there are several parts in this work. One is this the NLP, the classification part. The other one is test generation, genetic algorithm. There is the actual static analysis that extracts, that performs static analysis on the Android application. There are some limitations in each step. So, for example, test generation, at the moment, it's genetic algorithm based, but there are some challenges that we would like to improve in that regard. The static analysis tool has a limitation in the sense that it performs only intra-component flow analysis, but it doesn't support inter-component flow analysis. So, like improving it in that way, so that we will be able to have more precision and recall in the future. At the moment, we are focusing only in precision.
Okay, thank you. So very interesting work. If there are no more questions from attendees, we can finish here the question and answer session. So receive a virtual clap from all the attendees that are here. And if there is any attendee that would like to talk with the author, you can go to the discussion room and he will be there. Okay. So see you in the next session. This session is over. So bye-bye.
Bye-bye. Bye. Thank you, everybody.